4.0 question for Unit 6. And there are 3 questions on this page, but I'm just going to go through the first one as an example. So for this learning target, we are writing and solving a rational equation when we are given a context. So here we have a kayaker and they're spending an afternoon paddling on a river. She travels 6 miles upstream and 6 miles downstream in a total of 10 hours. In still water, the kayaker can travel at an average speed of 4 miles per hour. So based on this information, what is the average speed of the river's current? And we want to round our answer to the nearest hundredth. So I want to start by kind of circling important information. So I have 6 miles upstream and 6 miles downstream in a total of 10 hours. And then we also know that the kayaker can travel at an average speed of 4 miles per hour in still water. So how I want to start this problem is I'm going to kind of make a template for me. So I'm looking at my upstream plus my downstream, and that will equal the total. So I know my total time was 10 hours. So I know that's going to be equals to 10. So I used my 10 hours. Since I'm looking at upstream and downstream, I know I'm going to use the 6's. So 6 for upstream, 6 for downstream. But I also want to take into account the speed of the current. So when I set this up, I'm going to do my 6 miles and I'm going to divide by this speed. So I know that it's 4 miles per hour in still water, but since I'm going upstream, I'm actually working against the current. So because I'm working against the current, I'm going to subtract the current from that 4 miles per hour. Then I want to set up another fraction for downstream. Pretty similar, so my distance will go on top. It's another 6 miles downstream. They were both 6. And then in my denominator, I have my 4 miles per hour in still water, but since I'm going downstream, the current is actually helping me. So in addition to this is the current kind of like guiding this kayak down the river. So upstream, I'm subtracting the current, downstream, I'm adding the current. So this is how I would set up my problem. Now that I have the problem written out, I want to solve for C, which is the speed of that current. So I notice that I have some denominators here that I'm going to want to get rid of. So I'm going to multiply every single term, so this, and this, by both denominators to cancel those out. And I'm going to do it in one step. You could do it in 2 different steps, but I don't have that much room on this paper. So I'm going to do both 4 minus c and 4 plus c to all 3 terms. And then so now I want to cancel out what would cancel. These are getting multiplied into the numerator. So if I have 4 minus c and another 4 minus c in my denominator, those will cancel. And then here, my 4 plus c and 4 plus c will also cancel. So when I multiply this, I have 6 times 4 plus c. And then I have, for my middle term, 6 times 4 minus c, because that's what's left over. And then here I have 10 times both of these, and I'm going to multiply these together first before I multiply the 10 in. So 4 times 4 is 16 plus 4c minus 4c minus c squared. And I just distribute that out. So I want to simplify this. Here I'm going to distribute my 6 in, so I'll have 24 plus 6c, and then 24 minus 6c. I'm just going to simplify the inside here. 4c minus 4c will go away, so I'm left with just 16 minus c squared. On the left-hand side, I have a positive 6c and a negative 6c, so those would cancel out and be 0. I can combine those to give me 48, and then I'm going to distribute in that 10. So I have something that looks like that. I ran out of room. I'm going to subtract 160 from both sides, so I would get negative 112 equals negative 10 c squared. Oops, that's going to be a positive. When I divide both sides by negative 10, that's a positive 11.2 equals c squared. And then I just want to take the square root to solve for c. So when I do that in my calculator, I get about 3.35 miles per hour. So the current is going at about 3.35 miles per hour. So you can use this example to help you with the other two on the sheet.